Here is today's agenda. First, we will talk about the file sharing interoperability testing, includes the protocol test suite family and the test scenario design. Then we will run into the real test suite to see how the test suite being executed with a file server failover demo. First, let's take a quick look at the SMB3 dialects new features. In SMB3 dialects, we have several new features and enhancements, such as the transparent failover and the witness service to support the high availability, and as well some performance improvements, such as the SMB Direct, which could run SMB3 dialects over RDMA. Also, we added the new protocol named the FSRVP to support remote create shadow copies on remote file servers. For the security parts, we have the optional encryption, and also in SMB3 dialects, we now use the CMAC to send the message. Now let's take a look at the protocol test suite family. In this family, we contain the 3 protocols, include the updated SMB2 protocol, which contains the new revised SMB3 dialects, and also the new protocol SWN, which defines the witness service, and the FSRVP, which defines the remote shadow copy on the file server. In the test scenario of SMB2, we grouped several categories for our test case. First, we have the basic group to cover basic message sequence in previous dialects, such as SMB 2.1 dialects. And then we have an amount of new test cases to test a new feature of SMB3 dialects, such as multiple channel encryption, direct leasing, client failover, and server failover. For the server failover, we also integrated with the witness service, which introduced in the SWN protocol. And also, we have the new test scenario for the new LCTL or FSCTL codes, which was introduced in Windows 8 or Windows Server 2012. As mentioned in previous session, we also have the test in the CBAC environment, which categorized into 2 groups. For the test scenarios in SWN protocol, we have 3 scenarios, which test the 4 RPC method call. The get interface list and the register unregistered method, and then the async notification method. For the FSRVP, we have 3 scenarios. First, we test the basic call sequence to operate a remote shadow copy set. Then we focused on the specific context setting, such as backup, app rollback, NAS rollback, and file share back. We also have some negative test cases with the invalid context. And finally, we test the abort operation in different states, such as abort operation after add the shadow copy or commit the shadow copy. That's the first section of today's agenda. Then let's take a look at the test suite architecture with components. So, any questions so far? Okay, let's go move on. For our test suites, we have 3 components: the actual test case, and the stack SDK, and the SDOT control adapter, which could talk to the actual SDOT server to change the state or retrieve the state. These components are installed on our test driver machine, which act as a synthetic client. And we also have SMB server, SWN server, and the FSRVP server, which act as SCOT, which means the system under test. First, our test case will invoke the call from stack SDK and send the request over the network to talk with the SCOT. Meanwhile, our SCOT control adapter will invoke the requests on the SCOT to retrieve or change the status, and then we will compare, verify the state and the response. This is our test environment topology. In this environment, we have DC running the directory service, and a test driver machine which installed our test suite, and a 2-node cluster which acts as a SCOT server. And the storage installed for the cluster. If we need to test other implementation other than the Windows server, we could replace the SCOT server. After the test suite installed on the test driver machine, we have following folder structure. If we need to run a quick test, we could just click on the batch file in the batch folder. If we need to take a look at the source code, we could check the source folder. We also have the documentation ready in place in the docs folder, which contains the technical documents as well as the user guide to how to configure our environments or run the test suites. In the source code, we have following structure. The SCOT control adapter interface defines the interface which we could invoke to contact with the SCOT server. And here is the implementation written in PowerShell script of the SCOT control adapter. Below, we have the grouped test cases by protocol features such as FSRVP, SWN. And we also have flexible configure file which could updated during test execution if we change the environment or replace the SUT server.
Yeah. What is SUT stand?
SUT is a system under test.
System under test.
Yes.
Yeah. Here we have a cluster as a system under test.
Okay.
Which acts as a class server. So in this case, we will later have a demo to run test suite against Windows, and that Windows is our SUT. In the interoperability scenario, we can replace the Windows SUT as a partner's implementation. That means we can easily configure our test suite to run against partner implementation.
Yeah, to change the configuration file to reflect the environment you want to test, we could modify this deployment PTF configure. If you want to change the SUT server property such as computer name, domain name, and username, we could put the change here. If you want to run the cluster involved scenarios and use your own environment, we could make a change in this section. Also, we have the section tool for you to change the specific file, such as the cluster shell. Our SUT control adapter is defined in this CS file, and here is our PowerShell script implementation for the SUT control adapter interface. If we want to use the PowerShell script for this SUT control adapter, we could change the adapter type to PowerShell in the configuration file. This file. For the environment that could not be invoked by PowerShell script, we added a flexible interactive control adapter. The interactive control adapter prompts the message and the actions you want to do, and then set the properties after complete. If we need to use the interactive control adapter, we could set the adapter type as interactive. During the execution, there will be a wizard for you to take the action. After the action done, we could set a succeed, and the test case will be continue to run. To run the test suite in the environment, we could open the folder on the desktop. For example, open the ms-smb2 and select, just click the batch file, and the test case will be executed. We also have the options to run the test case from Visual Studio. It could be more flexible if you want to run several specific test cases. To do this, we open the folder on the desktop as well, and then open the test suite directory. In the test code folder, we just double-click the solution folder, solution file. After the solution opened from the Visual Studio, we double-click the VSMDI file. This is the test list editor file. Then we could select the test case you want to run and just click the run. The test case will be executed. After that, the test case result will be shown in the below, and you, if that is passed or failed, and you could double click into this item and see what's the exact log it is. Now I will give a demo about the server failover with the witness service. Our test suite acts as the SMB client and the witness client. A two-node cluster is running as the SUT server. On that cluster, we have a file server role enabled. And currently, the owner of the file server is node 1. First, our test suite will get an interface list on the file server. The file server will respond to the client. After retrieve the available interface, the test suite will register witness service on node 2. Then the client will send the async notify request for the further resource change notification. After that, our test suite will access the file over SMB3 on the file server. In this case, we will request a persistent handle so that the server will preserve the handle during failover. Now we disable the node 1 to simulate the failover. The witness service on node 2 reply the client with the resource unavailable notification in this case. Then our test suite will again request the async notify request. When the file server is online with the owner node node 2, the witness service will reply back to the test suite with the resource online notification. After that, we access the same file by reconnect to the file server and continue to the access. Now let's give a demo on how to execute the test case. Here I opened the solution file from Visual Studio, and this test case is the one we just mentioned in the call sequence. Let's select this test case and start to run. Yeah. Initially, we will initialize the cluster environment to make sure all is ready for test. Then we will get the owner of the file server and the access IP. First, the witness client will get the available witness interface. There are 4 interfaces available, and we will start to register witness on cluster node 2. After that, SMB client will start to connect to the file server. During create request, we will request a persistent handle, and after that, we will disable the cluster node to simulate file server failover. Currently, the node is the owner node is node 1. The client received the resource unavailable notification. Now, after the failover, the witness client will receive resource available notification. After that, our client will reconnect to the file server and read the content on that file. Finally, we will clean up the environment. Yeah.
Will this happen regardless of the interface that fails? So if the iSCSI interface fails on node 1, will it still switch over and make finish the file read?
iSCSI interface.
In fact, didn't you have an iSCSI interface on the back of each node 1 and node 2 going to the data? I saw that.
Do you mean the sense storage?
Yeah.
If the owner node changes, we could get the notification. Yeah, if the file server goes down or went up, we always get a notification.
I'm not sure that's.
Yeah. Simon, try.
If I understood properly, there's 2 interfaces on each server. There's the iSCSI on the back. Let's say node 1's still up, but his interface has failed. Is that still going to be recognized in the test?
So basically, this is a test topology of this test environment. So this is a backend storage here. Okay, so these 2 nodes construct of the cluster, and their 2 nodes both connect to the same storage. And then the client will connect to the cluster, and the cluster will point to node 1, for example, as its owner node. Okay, and then our test suite will simulate the failover and use some script or other technology to disable this node to trigger the server failover. And then the waitlist, when the server failover happens, the waitlist will reply with the message and notify the client, okay, this server is not available, and the file server service allow switch to node 2. And basically, because of these 2 nodes share the same storage here, so we can connect to the node 2 and continue the file share session.
I understand all of that clearly. This fails.
Yes.
Node 1 is still up. What happens?
It's still up. Okay.
Node 1 is still communicating.
Node 1 is still
But
communicating.
its backside file, the storage interface fails. Only that.
If the do you mean the backend as
No. The NIC on the iSCSI side.
this
Yeah,
NIC?
That goes
So-
away on node 1.
So the connect
Will we still see the failover occur?
still
The NIC,
no, and
If I can't communicate, so
Yeah.
Data's flowing this way.
Mhm.
You no longer get to it. It's still alive. The witness caused the failover to go to the second.
It's just a different failover.
Yeah, it's like should be. I was curious. But I wondered, is node 1 still there talking?
Right.
Yeah.
We can try it in the lab.
Yeah, let's.
I can answer. I advertised the storage before, yes. If this node is still alive, yes, the communication will be working. But because the cluster will take the ownership to this one, so the active process will change to this line,
Okay.
even though this is working. Yeah. So all the transfer will move to this. After this change, it include the file server. Yeah. So the cluster will automatically select the transport to this SCSI interface and then access to the storage. Yeah. Is it? Okay.
Test that.
Let's try it.
There's another question.
Yes, please.
So you talked about the method of what's the method of triggering the failure? Is there extra software needed on the server that the test uses to trigger the failure, or is it use a typical RPC connection or something?
The question is the method to trigger the failover, right? Currently, we disable the cluster service on the node to simulate the failover. That's one approach. We use SUT control adapter to talk to the SUT, such as the PowerShell script to invoke commands on the node 1 to stop the cluster service to simulate the failover.
So here, we use the SUT control adapter to interact with the SUT. This part can be replaced by any technology if you can talk. So in the demo, we use a PowerShell script. If the partner implementation does not support use a PowerShell script, we can use the interactive mode. Okay, so here, actually, here is a SUT console adapter interface, and then we implemented this interface using PowerShell script. This is a PowerShell script implementation of this remote control. If partner implementation does not support that, we need to, this is a configuration for the PowerShell. Okay, if the implementation does not support the PowerShell, we can use the switch to interactive adapter. That means we can use to do some manual work to communicate with the SUT system and then come back to tell the test suite what happened and then to continue the test suite running.
But if the server is not Windows, for example, we can inject our own script at that point, which would trigger a custom failure in a different way.
Yes. Yeah.
Repeat the question.
Oh,
Okay.
if the server is not Windows. Yeah.
So repeat the question.
We're going to repeat the question.
Okay.
Okay. So the question was, if you are not running Windows system, and how you want to trigger the failover, can you use your own method to either? Okay. So how do you use your own method to do it, right? So you can implement by using our interface, or you can manually. You can kind of manually trigger it, and then here you just, in this pop-up window, just tell us you already manually triggered it successfully, and then our test suite can continue run for you.
Questions? Okay, so maybe after 5 minutes, Indy will talk about the FSA test suite to all us. Thank you all.
Great. Thank you.